Welcome everyone, welcome to this year's edition of Meet.js Summit. My name is Tomasz Łakomy, I'm a software engineer at Ignite, and I'm very happy to be here. And I'm also very excited that I'm the first speaker to speak at this amazing stage today, because it means that once this talk is over, I can finally chill out in the audience with the rest of you, which will make me very happy. So today's talk will be about performance, mostly in the scope of React, but this is a Meet.js Summit, not React.js Summit, so I will not be talking only about React, so I hope it will be fun for everyone. So without further ado, let us begin. I'm going to start this talk by telling you a bit about our motivation, why you should care about the performance in the first place. And I'm going to take a bit non-technical approach here. I'm going to talk a bit about empathy, because I believe that we as developers community, we sometimes lack empathy to our users, and that's bad, honestly. And I also believe that as developers, we have a responsibility. We have a responsibility to our users to provide them with the best experience they can get, no matter what device, what network connection, or what browser they are using. Because speaking of devices, I believe that so many of us are living inside of this tech bubble. And what I mean by that is that it's not very uncommon for a JS developer to using a brand new MacBook, because I see 1, 2, 3, 4 in the audience. And the average users aren't like that. And I think that Paulo Coelho said it best, that your users won't have $3,000 MacBooks. It just won't happen. I mean, of course, some of them will, but this is not the reality of most people. And speaking of people, currently we have 7.5 billion people here on this planet, luckily not in the audience, and 3.8 billion are currently connected to the internet, which means that 49% of people are not yet online, but they will be at some point. And the number of people who are going online each and every single year is growing, and is growing massively. And I remember the first time I got online, it was absolutely magic. I was like 12, and I was so into this new web thing. And I believe that we should strive to give this kind of magic to all those people who are going to go online for the first time. And if they will go online, they will be most likely from mobile devices, because the 60% of web traffic is currently from mobile. So we should talk more about mobile. The first point I would like to make here is that JavaScript on mobile is costly. And I mean, it's actually literally costly. So this is a table from an amazing article by Ben Schwartz, and I strongly recommend you guys go ahead and read it, of course, after I'm finished talking. And it shows the number of hours you have to work in order to buy 500 megabytes of data in some countries. So think about this image. Next time you notice that your app is 5 or 6 megabytes, because in some countries, people will have to work for 2 days just to load your app 100 times. And honestly, I think we can do a bit better than this. This is another graph from Eddie Osmani. I know the letters are a bit small, but this is not the point. The point is it shows the startup performance of a certain JavaScript app, the amount of time it requires to parse and execute the JavaScript. And at the very top, we have a MacBook Pro, which is a very expensive piece of equipment. And of course, it's very fast. But as we go down this graph, you have older or cheaper devices, and you can see that this time is growing massively. And you cannot expect the same performance as on desktop as on mobile device, so we need to think about that. But luckily, everyone uses Chrome on Android, right? They don't? God damn it. Okay, let's take a look at the data. The most popular smartphone vendor is currently Samsung. The next one is Apple, no surprises here. The third one is Huawei. And the next one is Oppo. Then there's Vivo, and then there are millions of others. So it means that Oppo and Vivo combined are selling more phones than Apple does. And no one is optimizing for those devices. So we, as a developer community, we are missing so much of those devices, so many devices that are out there. And also speaking of browsers, the most popular is Chrome. Then there's Safari, again, no surprises. The third one is UC browser. I don't know about you, but I've never had a ticket to fix anything for UC browser, and this is 40% of the market. Then there's Samsung Internet, there's this browser that doesn't even exist, and then there's Android browser. So my point here is that we don't know the average user, because there are simply too many devices, too many possible network connections, too many browsers. So we should go ahead and optimize for everyone, because in the end, users matter, not the code. Because users don't care if you're using React or Angular or jQuery. what they care about, whether the app is fast, because they don't want to use your app. They want to be done using your app, so can just go ahead and move on with their lives. In general, I believe we should ship less stuff. So we should ship less assets, less code, less images, especially a point about mobile phones, because phones, if you go ahead to a mobile page and you download a new font every single time and it looks exactly the same as the one you have on your device, why not just skip the part of downloading the font and just go ahead and use the font that you have? Oh, by the way, this ship is not a typo, because I would like to meet you someone. His name is Shrek, and he's a sheep that got lost for 6 years, I believe. And as you can see, he's gained a significant amount of wool. And he also has a second nickname. He's the Average.js Bundle 2017. And our mission as a developer community should be to go from this to this. This is Shrek after they found him, minimize all this wool. So if you would like to find out whether you are basically shipping too much stuff, I strongly recommend you use something called code coverage, which is available in new version of Chrome. And what it does is it will actually show you what CSS and JS files were downloaded at the initial page load and how much of the stuff was actually used at the initial page load. So you can see that, for instance, this bootstrap here on a certain JavaScript conference site is not used at all. So you can just go ahead and skip it entirely. If you would like to minimize the amount of excess JavaScript, of course, you should minimize your code. And I would like to recommend Babily here, because the thing about Babily is that if you take a look at the very top, we have a simple JavaScript class. And down here, there's a result of minifying this class with uglify. So as you can see, it's converted to a function. But what Babily does, Babily is a part of Babel, so of course it knows ES6. It doesn't have to transpire this class to a function, because it can just go ahead and minimize the class itself. So in the result, you're going to get a smaller and probably faster code. Also another thing, I don't know about you, but some people actually go outside. And if you go outside, there are those things called trees. And if you go ahead to an older tree and just go ahead and shake it, you will notice that the old branches of the tree are going to fall down. So this is basically what Webpack tree shaking does with our code. It is available in Webpack 2 and 3. And what it does is going to shake the dependency tree of your code. And basically, it's going to remove all those unused dead branches, so your build will be smaller. OK, let's talk about React for a bit. The first thing and the most important thing I'm going to talk about here today is shipping React for production. I cannot emphasize how important this is. Not only is the development build of React like 4 times bigger, it also is around 10 times slower, because on development we have so many checks, warnings, and whatnot, which are absolutely unnecessary in production build. And if you'd like to know whether you are shipping correct build of React, you can just go ahead and click on the icon in React DevTools. It is going to tell you whether you are not using React at all, which is fine. If you are using an outdated version of React, development or the production one. So after you are back at work tomorrow or even today, just go ahead and click this icon if you are using React and check out whether you are using a proper version, because Slack recently admitted that they are using development in production, which is bad. Another thing that you can do is remove prop types from production environment. And one more note here, it can be risky because some libraries, for some reason, are using prop types in runtime, which is bad. You shouldn't do it, but they do it nevertheless. So a disclaimer here. This is a very simple class. I'm not expecting you to be able to read it, because the thing that's important here is those prop types over here are like 20% of the code. And this is what this looks like after minification. But the thing is about prop types, that in production environment, they are not used by React at all. That's literally an if statement saying, OK, this is the production, prop types are gone. So we should just go ahead and remove them, because this is basically a dead code. So there's a very handy plugin to do this. It's called Babel plugin. You know the deal. It's a bit long to read. By using this plugin, you can achieve results similar to this. So before I did a measurement on a production-ready web app, it was 240 kilobytes of code. And after we moved the prop types, it was 230. So 10 kilobytes less in general, 5% less code, just by removing those prop types, which is basically dead code. So free win, right? No more dead code in production environment. And this is what this component looks like after removing those properties. So you can see it's actually visibly smaller. And there are many Babel plugins such as this, and I will not be able to go through all of them because we simply don't have enough time. But if you are on your computer right now, you can just go ahead, check Babel React Optimized package on GitHub, which is a collection of Babel plugins, but some of them are risky, some of them may even break your production build, so please proceed with caution. Okay, let's talk a bit about runtime, shall we? Before we fix some things in the runtime, we should know how to measure our performance gains or losses. So there's a React add-ons perf package that you can go ahead and install. And what it does, you can run start, just click some buttons or whatever, then run stop. And then if you run print wasted, you're going to see exactly how much time was wasted by renders that didn't do anything of value. So this is a very good way to debug where you have performance hiccups or not. And if you would like to know in general how many unnecessary renders you have, you can use something called why did you update. This is a bit more talkative package because it tells you about every single unnecessary render that you have in your web page. So it could be, it could literally spam your console log, but it's useful nevertheless. Because in general, our approach should be to render as little as possible. React is fast, and that is awesome. But we, as developers, we shouldn't, take those things for granted, because if you do too many renders, it will basically just go to waste. The general rule is that if you do unnecessary renders, a cute panda dies, and there's like 200 of them left, so save the pandas, avoid the renders. You can do that by using should component update, which is a method from React lifecycle, which allows you to, based on current and next props and state, to basically decide whether you should just go ahead and update the component or not. Because in some cases, you might not want to update the component or never update it, so you can just go ahead and return false from this function. One more thing. You can use something called pure components with immutable data. Now, pure components are components that are a function of their props. So for any given props, they will always return the same DOM tree. So they are very pure in this regard. And immutable data, what immutable data does, if you have an immutable object, and if you just go ahead and modify a single field in it, it will return in a brand new reference to an object. You cannot mutate your data in place. So by combining those two things together, because pure components implement something called shallow rendering. So basically it checks whether your props have a different reference or not. So by combining those two things together, you can see, okay, with immutable data, I'm always getting a new reference if something has changed. So I can just go ahead and update my component. And this results in the minimal amount of renders, which is, well, pretty cool because you are going to save the pandas. And if you'd like to get deeper into your components and see what the hell is going on there, there's this amazing field called React Component Profiling. And this is from Chrome. This is in Timeline tab. And what you can see here, that previously in this file graph, we had all those internal React methods, and it was a pain to debug. So what we have right now, we have actually the names of the React components themselves. So you can see that, okay, this component took like 2 weeks to render, so it's probably a bit too long. So you can just go ahead and assign an intern to just go ahead and look at it. One last thing I would like to talk about here in this talk, and this is the thing that honestly is very exciting for me. This is called code splitting, also known as stop making users wait for unnecessary crap at initial page load. Because why? Why, as a user, I have to download a code for a settings page if I'm on the home page and I don't care because I might not use these settings at this point at all? So the thing I'm going to show you here is called dynamic import. You can use them today because they're available in stage 3 of TC39 process, so they will be in the language for sure, and they are supported by Webpack 2 and 3. And what it does, it allows us for dynamic function-like imports in our JavaScript code. So because you basically can import whatever you want, whenever you want. And it returns a promise, so it's quite easy to use. And the bottom line here is you don't no longer have to download a whole library like moment.js, only because you need to download, you need to display, a date on a single component somewhere in your app. And so I'm going to show 2 things here, dynamic imports and React loadable. React.debug is an amazing library that allows us to dynamically import React components. And they told me not to do a live demo here, because live demos are always bound to fail. So let's do it. Oh, this is my wallpaper, sorry. Yeah. So what we have here is a very simple app that I wrote, and I hope you can see it. Yeah, you can. It shows the React.debug in action. So React.debug, what it does, it takes an object as an argument, and this object has two fields. The first one is loader. So what it does is specifies a function. And this function tells you, OK, what should be important and how. So here I'm going to simulate a fake delay of 2 seconds, because of course I'm going to run it on localhost. I'm not insane. And then I'm going to dynamically import the example component, which I will show you in a minute. But the thing is that this example component is not loaded at the very beginning, so I'm saving user bandwidth. And if this loader function over here takes more than 200 milliseconds, you can just go ahead and use the loading component instead. Because the users need to know, OK, I'm actually waiting for something, right? So you cannot just display an empty web page. And this is a quick demo. So this is I'm going to refresh this page. And you can see here that at the very beginning, there was only one request. And after 2 seconds, bam, there's another. So this example component over here was not loaded at the very beginning. And by the way, yeah, this is code. It's not minified, and it's not minified on purpose. So I'm not shipping, 253 kilobytes of code for no reason. And this example component over here, what it does, it is a collection of, some popular JavaScript frameworks and libraries. And so we have React, jQuery, Lodash, and Angular. And I can dynamically import some stuff. And how it looks like in action, we can see over here. So for instance, this get jQuery button. What it does is going to dynamically import the jQuery. So jQuery was not loaded at this point at all. And then, after the jQuery has been imported, I can just go ahead and use it, because it returns a promise. And in this stage, I'm actually quite sure that the jQuery has been loaded. And you can see even better over here. I'm importing the moment.js, whole of moment.js, which is a pretty big library, just to display a current time. But the bottom line here is the user didn't have to load all this crap at the very beginning. So by going over here, I'm going to click the get jQuery button, get time. And you can see there were 2 more additional network requests. And I'm not sure if you can see it, but here's the jQuery. So it was actually it. It wasn't available at any point before. Another thing is that running dynamic imports a couple of times, it doesn't do anything more, because I'm clicking this get jQuery button, and it's not sending any additional new requests. Because the point here is to save the user's bandwidth, because they don't need to download all this crap at the very beginning. And you might have noticed over here that there's also a get awesome button. And what it does, this is the dumbest component I ever wrote. For some reason, it imports the whole of Lodash, Moment, Angular, jQuery, and React just to display a single div. So, of course, it's nothing practical, but it's a simulation that if you have a large component in your app, you can, instead of making those users download it at the very beginning, you can just go ahead and get it dynamically at the point that it's actually needed. And it's needed when I click this button. So I'm clicking this button, and there you go. I've downloaded more than 0.5 megabyte of JavaScript just to load a single div. Also, another amazing thing is that once this component is loaded, clicking any of those buttons is not going to send any request at all, because all of this stuff has already been imported. So there's no more point of importing this magnificent piece of technology such as jQuery once more. This concludes my talk. And I would like to, whoops, what the hell? OK, so live demo didn't fail, but the presentation did. Wonderful. So the bottom line, I would like to finish here, is for you to ship less stuff and deliver more. Thank you so much for listening.
Did you try to use Google Closure to optimize your code?
Well, to be exactly honest, I haven't had an experience with Closure, because there are simply too many approaches to minimizing those stuff. So No, I haven't had any experience with that.
Okay.
Not yet.
Okay, first thing about should component update is because
Oh, you're over here. Okay.
people just often use it incorrectly because just by running should component update, you might accidentally slow down your app.
Yes.
Because React reconciler is sometimes faster than your code written in should component update, so it's not always the best solution to use it. And the other thing is, sorry for asking two questions at once.
No worries.
The other thing is about bundling, because using Bubble itself, it creates a lot of useless code, especially if you are using like stage 3 functions. For example, if you are using async await, it creates around 2,000 extra lines of code if you compile it using Bubble. So we may think about dropping support for IE11, maybe.
Okay. Okay, so to answer your first question, of course, if you do, like I said, many unnecessary checks in your should component update, of course it's going to be slow. And that's why I recommended the approach of using pure components. So you don't have to, in your should component update, just go ahead and update 2 objects field after field, because those things obviously will take much time. And if you use pure components, you don't have to actually do this, because it basically does only a shallow compare. And checking those 2 references is very fast. And the point about Babeli, yeah, I believe this is something that is certainly of value, is that Babel, of course, adds much stuff. But yeah, this is a price that you have to pay, right? If you want to use async awaits, I mean, some people have been using those since last year. You, of course, need to make sure that you are aware of the fact that it will inject a couple of thousand of lines extra in your JavaScript code. Yeah, but nevertheless, proceed with caution with anything that is in Babel, and those use stage 0 in production.
So another question about React, surprise, because some of the people, because of licensing problems, might be switching to Preact, or because of other reasons. Do the same tools, apply to Preact? Like, removing prop types and this kind of things?
Okay, I'm not a lawyer, but I've read one article, so I believe this makes you qualified to answer this question. Well, the thing is that honestly, if the lawyers in your company are not not afraid of React license, I don't think you should be afraid. Of course, like I said, I'm not a lawyer, so first approach that I would like to recommend is just go ahead and ask the lawyers in your company if they are aware of this, a bit of a mess regarding licenses, and whether you should just go ahead and use them. And speaking of Preact, which is of course a great alternative to React because it's very, very small, as far as I know, if Facebook really wanted to sue you, they could do it nevertheless, because Preact is basically using the stuff that React invented. So I don't know, just don't get sued. This is the best approach I can imagine.
I wanted to ask about bundles, because in your code example, you had like 5 different bundles. So the first question is, how did you create them? What tool did you use? And the other thing is, you had this example of a component which was importing all 5 libraries, right?
Yes.
Did the download of the last bundle, the number 5, cause the previous moment, I guess, and one other library to be downloaded once again?
Okay, so to answer the first part, I'm using Webpack. So basically, it's over here. And you can use something called syntax dynamic import plugin. Like I said, it's available by Webpack 2 and 3, and also is well documented on the web page. I know it's surprising, a well documented thing in Webpack, but it is, so you can just go ahead and read it. And if you could just remind the second part.
You had this component which was importing 5 libraries.
Yes, this awesome one.
Yeah, and you have like 5 libraries imported here.
Yes.
But before clicking the button to import the awesome component, you downloaded 2 libraries. I believe it was Moment and jQuery.
Yes.
And the download of bundle number 5 caused
they are downloaded, and again, unfortunately,
those 2.
Like over here.
Yeah.
Yeah.
So you're downloading the same libraries twice.
Yeah, that's correct, and this is something that you should certainly take care of once you're using this approach. Well, to be exactly sure, it doesn't work this way when you are importing actual React components, so the stuff won't get imported twice. But if you are mixing those two approaches, so if you are using dynamic and static imports, you can obviously run in some edge cases such as this. So in general, you should be aware of whatever you are doing in your web app and try to optimize for the best. And one thing I forgot to mention, this approach is not for small web apps. This is for large ones that have like millions of lines of JavaScript and they actually weigh 5 megabytes. So proceed with caution with whatever you are using and test this stuff. But yeah, this is a very, very good catch. So once again, thank you all for listening and go ahead and follow me on Twitter.